Hello everyone, I'm making a short video to aid your understanding of derivatives of functions. So I will begin with the derivatives of powers of x. If I have y is x to the n, okay, then the derivative of y with respect to x is dy dx is gonna be n x to the n minus 1. Okay, that's the rule of differentiating powers of x. So we can start in the derivative. In the derivative, the odd index becomes a coefficient. Coefficient, and the new index is 1 less than the odd index. In the original power. Okay, so that's just a simple rule for differentiating powers of x. Okay, in the derivative, the odd index becomes a coefficient and the new index is 1 less than the odd index. Okay, sometimes instead of writing y is x to the n, we can write y as a function of x and we say f of x is x to the n. Okay, in that case, we prefer to write the derivative as, okay, f differentiated of x is gonna be n x to the n minus 1. So if y is a function of x, then the y by dx is the same as writing f derivative of x. Okay, those two are gonna be the same. So let's work out a couple of examples here to emphasize the point. The first is I have y is x to power 1.3, then my derivative dy dx, if I differentiate y with respect to x, then this odd power 1.3 becomes a coefficient, and then the new power is 1 less than the odd power, okay, minus a 1. So this is gonna be 1.3 x to the power 0.3. That's the derivative of y, okay, with respect to x. Okay, 2, 3, or 4 more examples about this. We have f of x is x to the power a half. Okay, then f differentiated of x is gonna be, we drop the odd power, it becomes a coefficient, and then we have a half minus a 1. So this is gonna be a half of x to the minus a half. Okay, so if I have y is x to the power, let me say 7 out of 3, okay, then dy by dx, which is the derivative, it's gonna be, okay, you can write this as x to 7 over 3 to show you're gonna differentiate this, and then you get this as 7 over 3 x to the power 7 over 3 minus a 1. Okay, this is gonna be 7 over 3 of x to the power 4 out of 3, because 7 over 3 minus 1 is 4 over 3. So this is how we go about powers of x. What about if the power is in the denominator? If I have y is 1 over x to the n, the trick is simple. First, used a rule of indices that says if you have 1 over a to the n, then this is a to the minus n. So we write this as y is x to the minus n. Okay, and then we find the derivative dy by dx is gonna be the derivative of x to the minus n. Okay, this shows, if I write this with the apostrophe, it shows I'm gonna differentiate, and this is gonna be minus n x to the minus n minus a 1. Okay, so if you want to write this in a smart way, you can write this as minus n x to the minus of n plus 1, or it's simply the same as writing minus n out of x to the n plus 1 if you want to go further with it and just simplify it as a fraction. So these are some of the things we do with the powers of x. If I have something like I have f of x, I keep alternating between y and f of x. F of x is 1 out of x to the power 5. Then I want to find the derivative of the square root of 1 over x to the power 5. Okay, rule of indices. This is the same as 1 out of x to power 5, then power a half. Okay, and this is going to be 1 to the power half, then x to the power 5, then power a half. Okay, a half. Okay, or if you don't want to go this far, you may write this first as, this is actually a shortcut. You write this as x to the minus 5, because 1 out of x to power 5 is x to the minus 5. Okay, and then rule of indices says that here we multiply the powers. Okay, so this was just simplifying to get the, we have not yet looked at the derivative, but we have just been simplifying that expression, just using rules of indices. So next we go ahead and find the derivative. Okay, this is going to be the derivative of x to the minus 5 out of 2. Let's get that derivative. Okay, this shows I'm going to differentiate. So if I differentiate, the old power, which is minus 5 over 2, becomes a coefficient, and then I have minus 5 over 2 minus 1. Okay, so what's minus 5 over 2 minus 1? That's going to be minus 7 over 2. Okay, so here you get this as minus 5 over 2 x to the power minus 7 over 2. You've got to be good at defining fractions. So I have f definitive of x is minus 5 over 2 x to the minus 7 over 2. I can write this as minus 5 out of 2 x to the 7 over 2. Okay, I have found the derivative. So that's what we do with the powers of x. Okay, it's all about dropping the old power to become a coefficient and then reducing, okay, the old power by 1 to get the power of the derivative. Okay, don't forget, if you have f of x is equal to x to the n, then the derivative is going to be n x to the n minus 1. I have seen this as a common mistake. If I have y is 1 out of x to the n, there are students who think that the y by dx is going to be 1 out of n x to the n minus 1. That's a common mistake. Do not do that. So we say it's not equal to. Okay, it's not equal to. Do not be tempted to think that, okay, if you have f of x is 1 out of x to the power 4, then f differentiated of x is just going to be 1 out of 4 x cubed. Don't do that. Okay, use a rule of indices here. Okay, we know that 1 over x to the n is x to the minus n. Then to find the derivative, okay, it's gonna be a minus. So here n is 4. Let me drop the n and put a 4. Okay, this is minus 4. So to find the derivative, then we just write the derivative of x to the minus 4, and this is gonna be minus 4 x to the minus 5. Okay, so do not, I'm repeating, do not think that this is true. No, that's not true. Okay, if you have f of x is 1 over, okay, x to the n, then this is not true. This is not true. Okay, so the last important result I'll talk about here is when y is equal to a constant, c is a constant, then the derivative, the y by dx, is equal to 0. Okay, if you have y equals to 4, it means that the derivative is equal to 0. If y is equal to minus 200, still dy dx is equal to 0. As long as y is a constant or f of x is a constant, then when you get the derivative, f differential of x is equal to 0. So the derivative of a constant is a constant. Okay. Now, what about a product of a constant and a power of x? If you have a constant, you have constant and a power of x, you have product of a constant. Okay, for example, we have y is equal to 2x cubed. Okay, how do we find the derivative when you have a coefficient and then a power of x? Because a product of a constant and a power of x is the constant becomes a coefficient. We have this as y is 2x cubed. Okay, so the y by dx, the constant is not affected, that coefficient remains, and then we go ahead and find the derivative of x cubed. But what's this? This is 2. The derivative of x cubed is 3x squared. And then we multiply 2 by 3 to get a 6x squared. Okay, so when you have a constant and the power of x, a product of a constant and the power of x, the constant is a coefficient, so that coefficient is not affected. Okay, if f of x is a minus 7 out of x cubed, then this is going to be minus 7 x to the minus 3. And then the derivative is going to be a minus 7. We'll just multiply with the derivative of x to the minus 3. So what's the derivative of x to the minus 3? This is going to be minus 7 into minus 3 x to the minus 4, because minus 3 minus 1 is a minus 4. So you get this as a 21 x to the minus 4. And you are done. Okay, so that's how we look at a constant and then a power of x. If you have a coefficient and a power of x, the coefficient is not affected. No, it will just multiply with the derivative of the power of x. Next, we talk about the derivative of a sum of functions of x. If I have y is a sum of functions of x, okay, it is the f of x plus b of x plus h of x. Okay, it does not matter the number as long as you are summing functions of x. Then the y by dx is the sum of the derivatives of the functions. So we get the derivative of f of x and add to the derivative of d of x and add the derivative of h of x. Okay, it does not matter even if you have 10, 20 functions, you just keep adding the derivatives of the functions. Okay, let's take an example. I have this polynomial. We have y is x to the power 4 plus 5 x cubed minus a 4 x squared plus 7x minus a 2. Okay, so what's the derivative of that function? The y dx, the y by dx. It's all about getting the derivative of each function. The first is the function of x, which is the power of 4. So we need to have x to the 4, find the derivative, plus the derivative of 5x cubed, okay, plus minus, so this is going to be minus the derivative of 4x squared plus the derivative of 7x, then minus the derivative of a 2. So what do we get when we differentiate x to the 4? This is going to be 4x cubed plus this is going to be 15x squared minus a 2 and a 4 is 8x plus 7 minus 0, because the derivative of a constant is 0. So this will give you 4x cubed plus 15x squared minus 8x plus a 7. That's the y by dx. So to find the derivative of the sum of functions, what we do, we find the sum of derivatives of the functions. That's it. Okay, differentiate each function in turn and then add together the derivatives. Okay, so I can work out some more examples here if you want. I can work out a few more examples. In the discussion today, we had this question. We're given f of x is equal, that was question 3, the first part, okay? The question 3 was about to compute the following derivatives. So we had f of x equals to minus 4.3 x to the power 1.3 plus 4x plus 3. So what's the derivative of this function? This is gonna be minus 4.3, then it's gonna multiply with the derivative of x to the 1.3, then plus a 4 is gonna multiply with the derivative of x, then plus the derivative of a 3. And this is minus 4.3. Okay, this is gonna be 1.3 x to the power 1.3 minus 1 is 0.3 plus 4. Okay, x to the power 1, the derivative of that, or derivative of x is 1, then plus is 0. So this is all about multiplying 4.3 by 1.3, and then we have the answer. The next question was g of x. G of x is the square root of 1 out of x to the power 5. So remember, this is the same thing as 1 out of x to the power 5, then raised to power half. I think I've done this. This is x to the minus 5 over 2. So the derivative of x is minus 5 over 2, x to the minus 7 over 2. Okay, we have done that in the introductory part of this class. The last question I'm going to discuss under powers of x, or powers of any variable. I have r as a function of t is 3t to the power 4 minus 2t cubed plus 3t plus a 1. The derivative of this function, okay, the rule is simple. Get 3 multiplied by the derivative of t to the power 4 minus a 2 multiplied by the derivative of t cubed plus a 3 multiplied by the derivative of t, then plus the derivative of 1. Okay, and this is gonna be 3 times 4t cubed minus a 2 times 3t squared plus a 3 times a 1, then plus a 0. So your answer is 12t cubed minus 6t squared plus a 3. Okay, and you are done. So that's what I can do for you. You can go ahead and work out more problems. You had this f of x is equal to 2x to the power 4.5 plus 4x plus 3x to the power 3 out of 8. So go ahead and find derivative of f of x. So you can go ahead and do that. That's your question.